All right, this is the sample test for Unit 3, Absolute Value Equations and Inequalities. It's the pre-Governor's School Algebra 2 only. The regular does not have this no calculator section, so just be sure you pre-gov. All right, let's start with number 1. We've got to solve an absolute value equation and state the solution. We need to either show algebra or we need to show graphically. I'll do both for you guys. If I'm going to solve graphically, I'm going to graph the right side. So I'm graphing y equals 8. Which is a horizontal line through 8. Then I'm going to graph the left side, y equals the absolute value of x minus 5. That's going to be a V shape that's moved 5 to the right. So 1, 2, 3, 4, 5 to the right. I make sure I have my slope counted off nice, and I'm going off the graph here. But I'll go ahead to the left as well. So where am I crossing? The solution to this equation are the two intersection points. On the left, I'm crossing at x equals -3. And on the right, I can't tell exactly where I'm crossing. I could just go by counting. So if this spot right here was at 5, then this was at 10. That's 11, 12, 13. So my second answer should be x equals 13. And I could always check that answer. Whenever I want to check any of my answers, I can always plug back into the original equation up here. So if I do the absolute value of -3 minus 5, is that going to equal 8? Well, I have a -8 inside the absolute values, so the absolute value of that is 8, and 8 equals 8. That's a good solution. If I plug in my 13, I'd have the absolute value of 13 minus 5 on the left side. That is +8. So again, the absolute value of that is 8, and 8 equals 8. That's what I had on the right, so both of those are good solutions. So that was solving graphically. If I wanted to solve this algebraically, the first thing I want to do is make sure my absolute value is by itself, which in this case it is, and then I'm going to split my equation into two parts. If x, whoops, that's minus. I'm not changing anything on the left side here. I have x minus 5 inside the absolute value. If that were positive, it would equal 8. I just dropped the absolute value symbols, but I don't have to do anything else. Then for my second equation, if x minus 5 were negative, it would have to equal -8. I'm taking the opposite of the right-hand side. Now I'm going to solve each of these equations. So I'd solve this equation by adding 5 to both sides, which gives me x equals 13. Over here on the right, I'd do the same thing. I'd add 5 to the second equation, and that would give me x equals -3. That's how I got my two solutions right here. Now, whenever I solve algebraically, remember I have to check. I could check either by doing the graph, which I already did, or I could check by plugging in, which I already did. So there's my two solutions. All right, moving down to number 2, again, I can solve this either algebraically or graphically. When I look at solving this graphically, though, and what's inside my absolute value symbols here, I'm not so sure how to graph that one. So I can tell that that's a V that's going to be stretched and it's going to be moved to the left some, but I'm really not necessarily sure exactly how much. If I were just ballparking a V up here, it would be something like that. And then on the right, I have the line x minus 3. So that's going to be a line with a slope of 1 and a y-intercept of -3. So right now this is looking like it's not going to have a solution, but let's go through the algebra just to verify since I'm not so keen on plotting those points. So my first step would be to isolate the absolute value, which I've already done. The absolute value is the only thing on the left side. Now I'm going to break into two parts. If what's inside were positive, it would equal x minus 3. If what's inside were negative, I'm going to drop the symbol and then take the opposite of the right. So that would give me a -x plus 3. Now I have to solve both of these equations. So over here, I'd move the x to the left side by subtracting. So I'd be down to 2x. And I'd move the 2 over to the right side by subtracting. So I'd have 2x is -5. Then I would divide both sides by 2. And I have x is -5/2. I'm going to have to check that in just a second. On the right side, I'd move my x over to the left to keep them positive. So when I add x, that gives me 4x over there. I'd move my 2 over by subtracting. That gives me 1. Divide both sides by 4 gives me x equals 1/4. Now I need to plug back into the original equation and check to see if this works. So if I'm plugging into the original, I'm going to plug in -5/2 for x And then on the right, I'm also going to have to plug in negative 5/2 for that x. Okay, right away I can tell that this one is not working. Whatever I have here on the left is going to be positive, and if I simplify the right-hand side, I have a negative number plus a negative number, so I have a positive equaling a negative. This is an extraneous solution. It did not work. Okay, let's try the 1/4 now. If I plug in 1/4 for x, again, even if you're not calculating exactly what it is, 1/4 minus 3 is going to be a negative number, and on the right we're going to have a positive number. A positive is never equal to a negative, so that's also extraneous. So this means our solution is that there's no solution. I can show that by writing the curly brackets and leaving them empty, or I could write out the words no solution. Whoops. Either one is fine, and my graph supported that. So things look good. No solution on that one. All right, so this next question I'm asking you to solve algebraically, and then in part B I'm going to ask you to do the same thing graphically. So let's start out and just do algebraically. Algebraically, I have to get this absolute value by itself. So the first thing I'm going to do is I'm going to subtract 1 to move it over the other side. So that would now be x minus 4 is 1/2 the absolute value of x minus 7. Then to get rid of the multiply by a half, I'm going to multiply by 2, which again is the same as dividing by a half. Be sure that when you multiply, you distribute to both parts, and it will now be 2x minus 8 on the left is the absolute value of x minus 7. All right, so now I'm ready to break my equation into two parts. I'm going to go ahead and think of the absolute value first because I like that on the left. If x minus 7 were positive, it would have to equal 2x minus 8. If x minus 7 were negative, it would have to equal the opposite of that. So that's negative 2x plus 8. Make sure you're distributing and changing that negative 8 to a plus 8. All right, now I need to solve each of those equations. So I'm going to get my x's on one side. I would move my x over by subtracting. So now I'd have only x on the left. I'd move my 8 over by adding. So that would be x equals 1. Over here, I would move my 2x over by adding it to get rid of the negative 2x. That'd give me 3x on the left. I'd move my 7 over by adding it, which would give me 15 on the right. Then I divide both sides by 3 to get the x by itself, which gives me x equals 5. So now I have two answers. I don't know if those answers work, though. I'm going to need to plug back into the original equation to check them. If I'm plugging in 1 for x, I would have 1 minus 3 equals 1/2 the absolute value of 1 minus 7 plus 1. So on the left I have negative 2. Now that's okay that I have a negative because over here on the right I have more stuff going on than just the absolute value. So I have 1/2, 1 minus 7 is negative 6. So then I have 1/2 the absolute value of negative 6. The absolute value of negative 6 is positive 6. Half of that is 3. So right now I've gotten, unfortunately, negative 2 equals 4. That is not true, so it looks like x equals 1 is an extraneous solution. Let's try x equals 5. If I plug in on the left, I have 5 minus 3. On the right, I have 1/2 the absolute value of 5 minus 7, and then the plus 1 on the end. So now on the left, I have a 2, which is more promising because it's positive. Inside the absolute value, I have negative 2. So now I have 1/2 the absolute value of negative 2. The absolute value of negative 2 is positive 2. Half of that is 1. So now I have 1 plus 1 on the right. 2 is equal to 2. X equals 5 looks like my only answer. So I'm going to write that in the spot for the solution. Let's confirm this graphically because that's the easiest way for me to double check that this really worked. So I'm going to start by graphing this absolute value. That's going to be my V shape. The minus 7 on the inside is going to move me 7 to the right. 3, 4, 5, 6, 7 to the right. The plus 1 is going to move me up 1. So let's get rid of that last point I just drew. And then I have the 1/2. The 1/2 is going to be my slope. So from my anchor point, I'm going to go up 1 over 2. I'm going to plot lots of points. If I'm solving by graphing, I want a nice straight line. Okay, then I need to graph the left-hand side. The left-hand side was x minus 3. That's a line with a y-intercept of -3 and a slope of 1. So it looks good that my lines are only crossing one time. Based on the slope of the red one and the blue one over here, I know that they're not going to cross again. I only have the one solution. The x value of the solution right there was at 5, and that's what I got as my answer, so I know I'm good. X equals 5. Again, I only want the x value of the solution, not the y value, because my original problem had x's in it. So part C says, explain why your answers to part A and part B should be the same. Okay, so solving algebraically and graphically are just two different methods for the same problem. So the answer should be the same for both. We're looking for what value of x makes this situation true. The only one that's going to work is x equals 5. We put this question on here so that you guys remember if you didn't get the same answer, you should go back and figure out what you did wrong. Okay, so now I'm on to the back where I'm solving inequalities, and I can again solve them graphically or algebraically. So I'm going to think of the left, or sorry, that's the right side of the inequality would be y is less than the absolute value of x plus 2 with a minus 1. So that's going to be a V shape that's been scooched 2 to the left and down 1. It's going to be a dashed line because there's not an equal to symbol with that. I'm making my line nice and straight here. And then it's a less than, so when I go to shade this, I'm going to need to shade down for less than. So I pick any points that I want to on the curve and shade down from there. And I'm shading, in essence, the outside of this V shape, all the down area. Okay, now I need to do the next one. If I'm looking at this 5, I have 5 is less than y, which means if I'm going to graph it the way I normally think of it, it would be y is greater than 5. So I'm going to go up to y equals 5, and I'm going to make a dashed line because there's no equal to there. This is a greater than, so when I shade for greater than, I'm going to shade up. It's pretty dark, sorry. Now I'm looking for the overlap of the two shadings, and you can see real clearly this darker blue over here is the overlap of the two shadings. There's some on both sides. So I need to figure out where my curves cross, and again I only care about the x value of those points. So that looks like we've got 4 over here on the right, and on the left we have, what's that, -8. So if I want to write this as an inequality, I need to show that at 8, I'm going to go to the left of 8 because that's where this part's shaded. And at 4, I'm going to go to the right of 4 because that's where this part's shaded. So on my number line, my 2 points I'd put on there were -8 and 4. When I graph, I have open circles because I didn't equal them. I shaded to the left for less than. I shaded to the right for greater than. If I were writing this as an inequality, I would say x is less than -8. I have to write the word or. X is greater than 4. The word or is important here. You can't be both things. You have to be one or the other. Okay, so now I'm also going to go through and solve this one algebraically. I need to get this absolute value by itself right here. So in order to do that, I want to move the 1 to the other side by adding 1. So I'd have 6 is less than the absolute value of x plus 2. I like the absolute value on the left, so if I'm going to switch sides there, if the alligator was eating the absolute value, the alligator is still eating the absolute value, I need to switch the symbol right there. Once I've done that, I'm ready to break into two parts. If x plus 2 is positive, it has to be greater than 6, or, because this is a greater than, it's an or situation. If x plus 2 were negative, it would have to be less than -6. So when I make my second part and I multiply this 6 by a negative to change it to the opposite, I have to flip the inequality symbol and make that a less than instead. Now I solve each of those. So over here I'm going to subtract 2 from both sides. So I have x is greater than 4. Or over here when I subtract 2 from both sides, I have x is less than -8. So my backup for checking this would be my graph, which I already have over here. And my solution, you can see, is the same thing, just written in a different order, but it doesn't matter which way you write it. Okay. All right, so number 5, I'm going to start out. I'm going to solve this graphically and algebraically for you again. I'm going to graph y is greater than or equal to 4x minus 1. So that's going to be a line with a y-intercept of -1 and a slope of 4. So I'm going to go up 4 over 1, up 4 over 1, or down 4, 1 to the left. For this one, I'm going to connect with a solid line because it has an equal to in it. And when I shade, this was a greater than, so I'm going to shade up. So I'm going to pick any point on my line and go up, and this is the portion of the graph that I'm shading over here. Okay, now I have to do the other part. So that one, get my pen here, I would have 2 absolute value of x minus 4 is greater than or equal to y. I like my y first, so when I write it, I'm going to have to switch the direction of the inequality. Y is less than or equal to the absolute value of 2x minus 4. So that's going to be a V shape that's scooched 4 to the right, and it's going to have a slope of 2. So I'm going to go up 2 on the right, up 2 over 1 on the left. And unfortunately, these are not meeting in a nice grid mark. So I'm going to have to see this meets somewhere over here between 1 and 2. I don't know exactly where, but that's okay. I might have to find it algebraically if I don't have a calculator. Oops, let me get a highlighter. And I am looking for when y is less than, so I'm going to pick any point on my curve and shade down. So I'm shading over here and then all over here as well. So my overlap is where it's turning the dark blue color, and that's going to be my solution set. So I need to find the number where these two cross. It's going to be something around 1 point something-ish. Whatever number that is, I'm going to plot it on my number line. It's going to be a solid circle because I had equal to, and it's going to go to the left because I shaded to the left. Not sure what it is. I'm going to write 1 point something right now. My solution is going to be x is less than or equal to whatever this 1 point something number is. I need to do some algebra to figure out the number. So let me do that. Let me get these out of the way so I have more space. Okay. Now, I need to get my absolute value symbol by itself, so I'm going to divide both sides by 2. I will have the absolute value of x minus 4 is greater than or equal to. When I divide by 2, remember I'm dividing the whole side by 2. So 4 divided by 2 is 2, and 1 divided by 2, I'm going to call that 1/2. Now I'm going to break it into 2 parts. If x minus 4 is positive, it has to be greater than or equal to 2x minus 1/2. I just leave everything the same. This was a great or then, so this gets an or. If x minus 4 were negative, I'm going to flip my inequality because I'm multiplying by a negative. It would be negative 2x, and the minus 1/2 would switch to plus 1/2. Now I need to solve each of those algebraically. So over here, I'm going to move the x over to the right, and I'm going to move the 1/2 over to the left. So let me erase that. I don't know what I had there. If I have my x moved over to the right, I have 2x. I would subtract x to move that over, so I'd have a single x. And when I move my 1/2 over, it's going to be adding 1/2. Negative 4 plus 1/2 is negative 3/2. So I have negative 3/2 is greater than or equal to x. I usually like the x first in my answer, so I'm going to flip that around and say x is less than or equal to negative 3/2. Over here on the right, I would move my 2x over to the left by adding it, so I'd have 3x over there. I'd move my 4 over to the right by adding it, so I'd have 4 plus 1/2 is 4/2. Then to get rid of my 3, I'd divide both sides by 3. So over here on the right, I have 4/2 divided by 3. Let's write that out. If I'm doing 4/2 divided by 3, in order to divide, I need to make my 4/2 into an improper fraction. So I say 2 times 4 is 8. 8 plus 1 is 9. So 4/2 is 9/2. And then instead of divided by 3, I'm going to flip it and call it multiplication. So it's 9/2 times 1/3. I'm going to reduce. 3 goes into 3 1 times. 3 goes into 9 3 times. And then I'll multiply straight across the top. 3 times 1 is 3. Straight across the bottom, 2 times 1 is 2. And I get 3/2. So I have x is less than or equal to 3/2. Well, 3/2 is 1/2 So this 1.5, you could either write it as 3/2 or 1.5, it doesn't matter, but that's going to be the number I'm talking about. So let's see what happened here with my answer. I really had two parts. I had this part of x is less than or equal to 3/2. So that was right here, my original circle shaded to the left. But I had this second part as well. So what's that? X is less than or equal to -3.5. So that will be somewhere over here going to the left. My answer of x is less than or equal to 3/2 covers my answer of 1.5. This was an or statement, remember? So I want to keep both answers, and my most concise way to write that is just x is less than or equal to 1.5 or 3/2. Okay. All right, number 6 here. I have, if I'm solving this graphically, I have y is less than 6. So that's going to be a dashed line at y equals 6. 1, 2, 3, 4, 5, 6. And when I'm shading that, I am going to shade less than, so I'm going to shade down. So all under here. And then for my second one, I have absolute value of x plus 8 is less than y. So if I flip that inequality, y is greater than the absolute value of x plus 8. So this is going to be a V shape moved up 8. And then when I go to shade that one, it is going to shade up for greater than. So I'm shading up here. I'm looking for where both of those things are true. There is no overlap in this one, so that means this never happens. And my final answer right here is going to be no solution, or the empty brackets. Let's try that again. No solution. And my graph is empty because nothing is shaded. There's no overlap. Okay. Be sure if your graph is empty, you realize that it really is not there. If this had been in all real numbers, then the entire graph is shaded. Okay, so let's look at number 7. It says Sally and Jane are working on the following problem together. Here's our problem. Sally wants to go through all the steps to solve the problem algebraically. Oh, we didn't solve number 6 algebraically. Sorry, just realized that. Let's go ahead and solve out number 6 algebraically real quick, and then we'll come back to Sally and Jane. If I wanted to solve number 6 algebraically, I've got to get the absolute value by itself. So I need to move the 8 to the other side. When I do that, I have the absolute value of x is less than -2. So we have when is a positive less than a negative? The answer to that is never, which is why we have no solution. If you had solved this the rest of the way algebraically, we would have broken it into 2 parts. We would have had x is less than -2. This is less than, so it's an and. I want to find when the absolute value is in between 2 things, right? So x is less than -2, and if I make my other part, I'd have x multiplied by a negative is greater than +2. So what I'd be looking for, if I made a number line right here, I want to find out where both of these things are true at the same time, where x is less than -2 and x is greater than +2. It's an and. I'm looking for the overlap. Where do these 2 graphs overlap? They never overlap. So that's how I can tell algebraically that it's no solution. Okay. So the opposite thing's going to happen down here with Sally and Jane. So what's the correct solution on this one? We have when is the absolute value, which is always positive, greater than or equal to a negative, and the answer to that is everywhere. So our solution would be all real numbers. If we were to make a number line solution, we would have shaded the whole number line everywhere. Anything you plug in, the left side is always going to be greater than or equal to the right side. So I pretty much just wrote down what I said above, which is that because the absolute value is always positive, and that's always greater than a negative, so any number you plug in for x, this is always going to work. All right, on problems 8 and 9, we're just graphing these two variable inequalities. So I'm going to start out for this one. I already have my y by itself. I have y is less than 2 absolute value of x plus 5. So I'm going to move up 5. And then my slope of my absolute value is going to be up 2 over 1. When I connect, I'm going to have to connect this with a dashed line because there's no equal to in the problem. And then when I shade my graph, I'm going to shade less than, so I'm going to shade down. So I pick any point on the curve and shade down, which means I'm shading this whole part out here and over here as well. Okay. All right, on the next one, number 9, I'm shading y is greater than, and on this one I have a V shape, a U shape because I've got a squared. So my parent function is a parabola. I am going to move 1 to the right because I have a minus 1 on the inside and minus 3 on the outside, so down 3. My shape for a quadratic is 1 squared is 1, so I go over 1 up 1 in each direction. 2 squared is 4, so I go over 2 up 4 in each direction. 3 squared is 9, so I go over 3 up 9 in each direction. These, again, there was no equal to symbol, so I'm going to draw a dashed curve on this one. And when I'm shading, I am shading a great or than. So greater is going to be up. So I pick any point on the curve and go up. And this one, the whole inside of this U shape is shaded. All right, on 10 and 11, we're working backwards. I'm giving you the picture and you are telling me the inequality. So I'm going to start out with my y first. So here I have a y. When I go to do my inequality, the shading part was down, so I'm going to make a less than. My line was dashed, so there's not going to be an equal to underneath that less than. I've got to figure out, it's an absolute value graph, it's a V, so where have I moved? I've moved 1 to the right, so inside my V, I'm going to have an x minus 1. I've moved up 2, so on the outside of my V, I'm going to have a plus 2. I also need to double check the slope of my V. From here, I went up 1 over 1, so I have not messed with the slope of that. Even though it looks a little flatter, I'm still going up 1 over 1 each time, so there's no number out in front. And that's it, I'm done. All right, on my second one over here, I'm going to start out with my y first. On this one, I've shaded up above, so that's going to be a greater. And then my curve right here is solid, so I also need an equal to underneath. My shape for this graph is a quadratic. It's an x squared. And I want to think of where I've moved. I've not moved at all left or right, so there's nothing inside there with the x squared, but I have moved down 1, so I need a negative 1 out on the end to move down 1. I also need to think about the shape of this. I've flipped over, so I need a negative out in front, and my normal shape would be to go over 1 up 1, but instead I would be going over 1 down 1, but I'm not going over 1 down 1, I'm going over 1 down 2. So I've doubled the amount that I should be going down, and that means I need a negative 2 in front for my stretcher. So I could also write this without the parentheses as y is greater than or equal to negative 2x squared minus 1. Since there was nothing else in the parentheses with the x, either one is fine. Okay, on to the calculator part. So this is the calculator active portion. It doesn't mean that I need a calculator to solve it. It just means that I'm allowed to have one. So on these, I'm writing the absolute value equation or inequality, so I'm working backwards. So I know I've got something inside my absolute value. I've got my x. I want to figure out, since the absolute value is a number's distance from 0, what I've done is I've got somewhere in the middle of this that I'm spreading out from. So I'm in between two numbers. I need to figure out how far apart those two numbers are. To get from negative 3 to 11 is 14 spaces, which means that I'm going to go 7 in each direction from my center. If I go 7 spaces, then that puts the middle of this graph right here at 4. And then we could just double check. If I do negative 3 plus 7, that gives me 4. 4 plus 7, that gives me 11. So the middle of my graph is at 4. Well, my middle of my graph should be at 0 because absolute value is a number's distance from 0. To shift the center of my graph 4 units to the right, I need to put a minus 4 on the inside. It needs to be minus 4 because I always do the opposite direction I would think on the inside. Then I want to say what I'm doing. My inequality for this one, my distance has to be within 7 units. So it can be a small distance or up to 7 as the distance. So that's a less than, and 7 was this distance that I traveled. So there's my inequality. All right, on number 13, this is not an inequality. I just have the 2 dots. So when I'm writing my absolute value, it's going to be an equal. So I need to figure out where the center is and how far I went in each direction. To get from -1 to 7 is a total of 8 spaces. So that means I'm going 4 in each direction. So the center of my graph is right here at 3. To move my center 3 to the right, I put a minus 3 on the inside. And then I'm saying that the distance that I'm going out is exactly 4 units. So that's why I have equal to 4. I can go exactly 4 units in either direction. By the way, if you wanted to check your answer to either one of these, you could just plug in a value. If you plugged in 7 for this x, would that work? Is the absolute value of 7 minus 3 equal to 4? Yes, it is. How about if I plugged in the -1? Is the absolute value of -1 minus 3 equal to 4? Yes, it is. So I know I'm good. All right, number 14, I've got my absolute value again. In this case, I've got to find the center. Realize this point is at 1. So to go from 1 to 9 is a distance of 8. So I need to go 4 units from either end. Putting my center right here, the middle of this graph is at 5. If I do 1 plus 4, that's 5. If I do 5 plus 4, that's 9. So I'm looking good. How do I shift my graph 5 units to the right? I put a minus 5 on the inside. I have solid dots here. So if I have solid dots, I know there's going to be an equal to. But with my inequality, my distance has to start out. You have to go at least 4, and then you go further. So I have a big distance from my center. A big distance would be a greater distance. And then how far I went out in each direction was 4. So that's the other side of my inequality. Again, I could plug in 1 and 9 and check and see that this works. Or I could pick a random big number and make sure that it works, and a random small number and make sure that it works. All right, number 15. So in this one, I can see these are all equal to's. That's good because I have my 2 solid dots. I need to figure out where the center of this thing is. So in order to figure out the center, I'm going to think, how far did I go? From -2 to 9, that's 11 units. So that means when I half that this is not going to be a nice number. If you took the average of -2 and 9, you're going 5.5 in either direction. So where does that put me? That puts me at 3.5. Okay, so when I'm writing my inequality, or my equal to in this case, I have x minus 3.5 to shift 3.5 to the right. From there, I go out 5.5 units in each direction. Now this one's different because it says select all that apply, and it gives me answer choices. These answer choices over here on the left already have a 2 out in front. So what I got is not there. So I got this, but that's not there. So what would happen if I put a 2 out in the front? What would happen if I multiplied by 2? If I'm going to multiply by 2 on the left, I'm going to have to multiply by 2 on the right. So when I do that, that's going to give me, if I leave the left side the same, 2 times the absolute value of -3.5, and on the right, 5.5 times 2 is 11. So that's this inequality, or equation. The other thing that I could do is I could distribute this 2 inside my absolute value symbol, which would give me the absolute value of 2x, and then my -3.5 times 2 would become a -7, which would be my second answer. So this one has 2 answers. I would go ahead and show your work like this, so if it's not correct, you don't select the right things, that you could still get some partial credit. All right, now I'm solving equations and inequalities, but I'm allowed to use my calculator this time. So I'm going to go ahead and I'm going to pull up a calculator. Let me scooch that over here. Um, so it says that I need to show my work. I can show my work by sketching a little graph. It doesn't have to be perfect. So I'm going to go into my y equals, and I'm going to start out, and my first thing I'm going to graph is y equals the right side. So my y1 is going to be 2x plus 9. Sorry, that's my little y1. And then my y2 will be the other side. I don't have to worry about flipping an inequality here. That's 3 times the absolute value of x minus 1. And it doesn't matter whether you have a TI or a Casio, this part here would be exactly the same. So I go into my y equals. My first one is 2x plus 9. And my second one is 3 on the outside to get the absolute value. I can go to alpha and F2, and that's where it is. Or I can go to math and over to number and get it there. Either one works fine. And I need to put my x minus 1 inside the absolute value symbol. Remember that if you're using this and you don't have the pretty print on your calculator, or you're running your app and it won't run the pretty print, that the way you should write this, it should have the 3 on the outside, and then it will say ABS, and then we need to put this x minus 1 in parentheses. Wherever these symbols are, you need to have parentheses for those on your calculator. Okay, so now I want to graph this. I'm going to go to a standard window, so I want to go to a zoom 6 for a zoom standard. And I know I should be getting a V and a line. I can tell that my V and my line cross once right now, and I can find that by going to second calc. The intersect is number 5. I move my blinker close to where they cross. I hit enter for the first curve, enter for the second curve, and enter for the guess. It gives me an answer of x equals negative 1.2. So I'm going to write that one down. Okay, I put this one in curly brackets because I can tell on my number line that would just be a solid dot. And let me get back my calculator. I could tell that I'm going to cross again somewhere up here. I can't see that on my calculator right now though, so my calculator's not going to find it until I do a little zoom out. So I go to zoom, I choose out. Now my calculator's waiting for me to hit enter. So I can either move the blinker close to where I want to zoom out around. It probably isn't going to matter, but I have to hit enter or it's not actually going to do the zoom. So now I can see the second place where they cross. So I'm going to go back to second calc, the intersect again, and I'm going to move my blinker over close to where they cross, and I'm going to hit enter, 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 and it gives me my second intersection is x equals 12. By the way, if you were using your Casio for this, once you found the first intersection, again, you have to zoom out so you can see it, but once you find the first intersection, you just hit the over arrow and it will just jump to the second one for you. Okay, so these were not that pretty numbers. I'm not going to bother doing this algebraically. It's faster for me to do it on my calculator. All right, number 17. Again, this one's an inequality. So I want to graph y is less than 12. And then for my second inequality, I'm going to flip the inequality to a greater than when I'm putting in this side over here. I've got the absolute value of 3x plus 7. And then the minus 25 on the end. So in my calculator, if I'm in my TI, in order to do the inequalities, I want to go to the apps. So I'm going to go to apps and I'm going to choose the inequal. It says press any key. So I'm going to clear this first equation. Oops. My first equation was just 12. In order to have this be a less than, I highlight, put my blinker on the equal sign, and then in order to get one of these buttons down here, I'm just going to hit the alpha button first. I want alpha, and then I'm hitting F2 for the less than. And you can see it changes my symbol for me. My second inequality, I'm going to do alpha greater than. And you can see I've lost my pretty print right here. That's okay. I'm just going to clear that out. I need to get the absolute value. If I try to do the alpha method of getting the absolute value, the F1 button doesn't work this time. I need to hit math, and absolute value is over a number. So I hit enter. The 3x plus 7 has to be inside the absolute value symbol. and then the minus 25 is on the outside. By the way, if you are using a Casio, you just look when you're in your y equals menu, somewhere around here it says type, and if you hit F6 to turn the page, you can see your inequality symbols, so you don't need to run an app on that. I'm going to go back to a Zoom 6, a Zoom standard, and you can see I'm graphing an inequality, so I've got one set of shading and I've got another set of shading. I know that I should have a line, a horizontal line, and a V shape on this one, but my numbers are pretty big. I've got a 12 and a 25, so I'm going to go ahead and zoom out. So zoom 3, and then I hit enter. So now I can see the 12 real nicely. Let's see if the 25's fitting on there. The 25 looks like fitting on there as well. And I can do two things since I'm running the app. I could either just look at the picture, or I can go to find the intersection. If I want to find out exactly where this point of intersection is right here and this point of intersection is, I'm going to need to use the calc button. I can tell that the area I've shaded is this part in between the two, and that should make sense because my problem over here, this was a less than, and less than is usually an and, right? So I just need to find those two places where they cross. So I'm going to go to second calc. I want the intersect. I'm going to move my blinker over here close to where they cross on the left, and I hit enter, 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 and it says they cross at negative 14.66666. So I should realize that's negative 14 and 2/3. Hopefully we know that. If not, you can put the decimals. Negative 14 and 2/3. Now when I'm plotting this on my number line, this was just a less than. There was no equal to, so that's going to be an open circle. And I know I'm going to be shaded in between. When I'm writing this as an inequality, I'd have negative 14 and 2/3 is less than, oops, no equal to, sorry, is just less than x, which is less than, now I need to find the point on the right. So let's go back to my calculator. In order to find the point on the right, I need to repeat this process. If I'm using my TI, if I have my Casio, I just hit the over button. Move over close to where they cross, hit enter, 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 and this one was 10. So I have negative 14 and 2/3 is less than x, which is less than 10. Good. All right, now I'm on to my applications. Oh, I didn't sketch any work. Sorry, I should do that. It said to sketch a picture if your work is graph. So I had a V shape like this. I had a line shape like that. I was in between. I was at negative 14 and 2/3. And I was at positive 10, which I would have gotten both of those off my calculator. I don't think I ever sketched my picture that I did up here either, did I? Nope, I didn't. So on this one, I had my V shape that was scooched one to the right with a slope of 3. I had my 2x plus 9, and then I crossed right here and right here. So these are just loose sketches. They're not rocket scientist graphs. It's just to give me an idea that I can tell that you understood what you were graphing. Okay, let's move down to our apps. So you're planning a car trip, but you don't know how long it will take. Your friends that it said that it should take 4 hours, give or take half an hour. It says write an absolute value inequality to represent the situation for part A. And then part B says what are the possible lengths of your trip. Depending who you are, I like to do part B first for this one. So how long might my trip take? I know that I'm centering at 4 hours, right? And I could go plus a half an hour, which would put me at 4.5 hours. Or I could go minus a half an hour, which would put me down here at 3.5 hours. So the possible lengths of my trip are 3.5 hours is less than, I would say, or equal to probably, give or take half an hour. I would assume that we could take half an hour. Exactly. 4.5. Okay. So this is my possible lengths for my trip. That helps me to write my absolute value inequality. So I've got my absolute value. I'm calling it H for hours. And I know that where am I centered on? I'm centered on 4. 4 was my average time. So I'm going to take my hours minus 4 to make my center move 4 to the right. Now, I want this distance to be a small distance. I want to be within a half an hour. So this is going to be a less than. Like I said, I think it's going to be an equal to because I could actually go exactly half an hour. And then I want to do how much did I go out in either direction? Well, I went out half an hour in each direction. So what I'm saying here is my times distance from 4 hours has to be within less than or equal to a half an hour. So there's my inequality. All right. Number 19, you're a quality control inspector at a bowling pin company. A regulation pin must weigh between 50 ounces and 58 ounces inclusive. That means they're allowed to equal that exactly. Write an absolute value inequality describing the weights you should reject. So what we want is between 50 and 58. What we don't want is the ones that are beyond that interval. So if I were looking at a number line, and I have 50 and 58. All the good bowling pins are between those, but my rejected pins have to be less than 50 or greater than 58. So where am I centering my absolute value inequality right here? Right smack in the middle would be 54. That's what they want the bowling pin to weigh. So I would have x minus 54 on the inside to move 54 to the right. Then when I go to choose my inequality symbol, I want big distances because I want the outside. So that means I have to be greater than, and I am going to be okay with pins that weigh 58 and 50 because those were the inclusive ones. So I'm not going to put an equal to symbol on this one. And then my distance has to exceed how far did I go in each direction from 54? I went 4 units in each direction. So I have a goal weight of 54 ounces, and I can be plus or minus 4 ounces to stay a good weight, but I am going to reject anything that is more than 4 ounces off of my average. All right, number 20 says the specification for the width of a World Cup soccer field, W, is 64 is less than or equal to W is less than or equal to 73 meters. So the field has to be between 64 and 73 meters wide. Write the specification as an absolute value inequality. So sometimes it helps me to look at it this way. Again, here's 64 and here's 73, and I want to be within those two numbers. So this is going to be a close distance. So when I'm writing my absolute value inequality, I want to be within, so less than or equal to, because these were both equal to's when I wrote them. And I just got to figure out how much my amounts are. Well, between 64 and 73 is what? That's 9 units that I just went up. So that means I'm going to go 4.5 in either direction. So my distance, my range of meters is the 4.5. I need to figure out where the middle is. So I could either just say 4.5 up from 64 is 68.5, and then just double check, does 4.5 up from there put me at 73? Yes, it does. The other way I could do that again is to average 64 and 73. Either way, I need to move 68.5 meters to the right, and that's my inequality. All right, number 21 has an election poll predicting 72 million voters supporting candidate A. The margin of error is 3%. So it says for part A, what is the highest number of people that vote for candidate A? So if there's 72 million, that's 6 zeros, and the margin of error is 3%. So that means I could really add on 3% of that. So I'm definitely going to want a calculator for this one to set up laziness. I'm taking, where's the calculator? I'm going to quit out of here. By the way, I probably would quit running the app. I just like to leave it not in the app. 72, 6 zeros. If I want to add on 3%, I'm going to multiply by 1.03. That's 100% plus 3% more. And what does that give me? That gives me 74 million 160,000. Okay. 74,160,000 is the highest number of people that might vote for candidate A. All right, so it says write an absolute value inequality to model the possible people voting for candidate A. So our margin of error had to be within 3%. So we're going to be less than to keep our within distance. If I wanted to think of this visually, my upper limit right here is the number that I just found, the 74 million number. I would need to find the lower number. I know my middle number is my 72 million. So on the inside of my inequality, I'm going to be x minus 72 million. That didn't fit real well. It's okay. Just scooch that over a little. All right, so I'm centered at 72 million. I can go up or down 3%. So what is the 3%? Well, 72 million times 0.03. This is just really the difference, the 2,160,000. But again, you could use your calculator for it. That's fine. I've got 2,160,000 because that's how far I went out in either direction. So there's my inequality. I think you could make an argument for whether it could be an equal to or a less than. It doesn't matter to me. All right, let's go down to number 22. That's our last problem here. We've got a snowstorm. It begins as flurries, builds up to a blizzard, and then drops back to flurries. The rate in inches per hour at which it snows is given by this function, where t is the time in hours, and we're supposed to graph the function. So let's start out down here on our x-axis, and that's going to be t in hours. And what kind of hours are going to make sense right here? If I look at my numbers in my problem, I'm going to shift 3 hours to the right. But I've got a slope of 2/3, so I could probably, make this count 3, or I could count them each unit as halves, either one. I could count them as ones or halves, doesn't really matter. So I'll shift 3 to the right. I'll count each one as 1 unit. Okay, now I'm also doing my vertical axis. My vertical axis is r. That's my rate, and that's inches per hour that it's snowing. I think it's easiest for me when I'm counting slope to make my scale the same on both axes, so I would make each 1 unit here as well. All right, so let's put this on the graph. Where do I scooch? I scooch 3 to the right and up 2. And then my slope here is negative 2/3. So I'm going to go down to 3 to the right or down to 3 to the left. Either way. I'm a negative, so I flipped over, and 2/3 is the slope of my v. I'm going to stop it right there when it hits the axis. So it says, for how long does it snow? Well, time 0 started out when it started snowing. That would be 6 hours when it stopped snowing. So it snowed for 6 hours. And I'm going to be sure I put units. I'm not just going to say 6. I'm going to say 6 hours. And when does it snow the hardest? Well, when it snows the hardest is when the rate is the highest, which would be right here. It's snowing 2 inches per hour, and that happened at 3 hours. At 3 hours after the snow started. I think I'm already happy thinking about future snow days. All right, so here we're going to graph these functions and state the requested information. Number 23, we've got f of x is 2x plus 5. So we should know our parent function here is an x, which is a line. The plus 5 on the end moves us up 5. So that's where we're going to start from. The times 2 out in front stretches us vertically by 2, so our slope is 2. We go up 2 over 1, or down 2, 1 to the left. And I'm making my sketch of my graph there, arrows on both ends to show it keeps going forever. So the domain of this function would be x such that x is an element of the reals, because it does go left and right forever. And the range is also y such that y is an element of the reals, because it goes up and down forever. The zeros are the x-intercepts. So this thing here, it doesn't exactly hit at 2. It hits right between -2 and -3. So with my 0, I write it as x equals -2.5 or -2.5 or -5/2, however you want to write that. My x-intercept I usually write as a coordinate, so -2.5 comma 0. My y-intercept would be where I touch the y-axis, which is up here at 5. I write that as a coordinate, 0 comma 5. And then I have to describe where am I increasing and decreasing and what is my end behavior. So I'm going to go ahead and I'm going to sort of write coordinates, if you would, for these arrows on the end. This arrow is pointing to the right, so x would be a positive infinity. It is pointing up, so y would be a positive infinity. This arrow is pointing down, so x would be a negative infinity. I'm sorry, it's pointing to the left, so x would be negative infinity, and it's pointing down, so y would be negative infinity. So what am I doing on this piece? As I go from left to right, I'm going up, so I'm increasing. So I'm never decreasing for this because I have to go from left to right. I'm increasing. I start at negative infinity and continue to infinity. So negative infinity is less than x is less than infinity. Also down here, I have the end behavior. As x approaches infinity, y approaches infinity, and that's that arrow up there that I just scrolled off the screen. And as x approaches negative infinity, y approaches negative infinity. And that's this arrow down here. When x was negative infinity, y was positive infinity. All right, great. Let's go ahead and do question number, oh, my board's not moving here, 24. So I look at this parent function, and this parent function for g of x is an x squared function, which means I know it's going to make a U shape. The -3 on the outside moves me down 3, so that's where my graph's going to start. My shape for an x squared would be 1 squared is 1, so I'm going to go over 1 up 1. 2 squared is 4, so from my anchor point I go over 2 up 4. 3 squared is 9, so from my anchor point I'm going to go over 3 up 9. And then when I square a negative, it's the same thing as if I squared a positive, so I'm just going to balance these points out over on the other side. I've got a U shape, I've got arrows on both ends to show that I keep going up. For my domain then, I do go forever left and right with that, so my domain is x is an element of the reals. My range does not go up and down forever, it has a restriction. Y starts down here at -3 and then goes up from there, so y such that y is greater than or equal to -3. The zeros are the x-intercepts, which I have one here and one here. I could recognize that that's the real number for that is the square root of 3, because if I'm looking for when does this function equal 0, it would be the square root of 3 and negative square root of 3. Or I could just use some decimal answers of about -1.7 and positive 1.7. If I'm not using my calculator, I'm really just ballparking anything between -1 and -2 there would be great. I also need to write those as coordinates. Whoops, I forgot a 1. -1.7 comma 0 and positive 1.7 comma 0. My y-intercept is where I touch the y-axis down here, which was at 0, -3. When I go to do my increasing and decreasing, let me write that point down. That was 0, -3. I also want to label my arrows. So this arrow over here is on the left, so x would be negative infinity because it's going forever to the left. It's also pointing up, so the y for that arrow would be positive infinity. This arrow over here is on the right, so x is positive infinity, and it's pointing up, so y is also positive infinity. So where am I increasing? I am increasing on this piece, where as I go from the left to the right, I'm going up. I have to use my x values for where I'm increasing. So I start at 0, which is less than x, which is less than when I stop, which is positive infinity. Where am I decreasing? I'm decreasing on this piece over here from the left to the right. That piece starts at negative infinity and goes until 0. So for that one, I'm going to write negative infinity is less than x, which is less than 0. All right, I also need the end behavior on there. Let me just shrink this down a little. That might make it easier. So I have my two arrows. This arrow over here on the left was x is negative infinity, y is positive infinity. That's going to be this one down here. X is negative infinity, y goes to positive infinity. My arrow over there on the right was when x was positive infinity, y was also positive infinity. So as x approaches positive infinity, y approaches positive infinity. All right, let's scroll down here to the bottom of the page. Hold on. All right, so I scrolled down and I just copied over here, g of x was x squared minus 3 from up above, and f of x was 2x plus 5 from up above. So this problem is asking me to find g of f of x. So what does that mean? That means that I'm going to start out with my g, and then, oops, there's my g. Into my g, I'm going to plug in f of x. So remember, if this has an x in it, your answer is going to have x's in it. So what's my g of x function? My g of x function was x squared minus 3, but instead of putting an x in there, I have to put in the whole 2x plus 5 function. Now I need to simplify this. When I have 2x plus 5 squared, that means 2x plus 5 times 2x plus 5. So 2x times 2x is 4x squared. 2x times 5 is 10x. 5 times 2x is 10x, and 5 times 5 is 25. So when I take this binomial here and square it, that gives me 4x squared. In the insides, I have 10x and 10x, so that's plus 20x. And then I had plus 25. Now don't forget, I also had this minus 3 on the end there. So my last step is just going to be to put that all together, which will give me 4x squared plus 20x plus 22. And that's my final answer. I can't combine anything else because I don't have like terms. All right. So on my next one, I have f of, so that's the outside letter comes first. Then I'm plugging into that g of negative the square root of 5. So the first thing I need to do here is I need to find this g of negative square root of 5. Since I'm plugging in a number, I shouldn't have any x's left in my answer. So again, the first thing I'm going to find here is my g of negative square root of 5, which means into my g of x function, which was x squared minus 3, I need to plug in negative the square root of 5. If I take this negative and I square it, it will turn positive, and the square root of 5 times the square root of 5 is just 5. Now I have 5 minus 3, which is 2. So this is not the answer to the problem, but it's an answer I need to solve the problem. G of negative 5 was 2. That is what I'm now going to plug into f. F was 2 times x plus 5. But instead of x, I'm plugging 2 in for that. And now I just need to simplify. So I have 2 times 2, which is 4, and 4 plus 5, which is 9, and 9 is my final answer. All right, in the last one, we're trying to find g, and then when we put this little negative 1 in the exponent right there, what does that mean? That means the inverse of g of x. Inverse is the opposite. So I'm going to do the opposite of my g function in every way, shape, and form. My g function was up here again. So my g function was an x squared. The parent function for the inverse is going to be the opposite, which is going to be a square root of x function. In my function, I had a minus 3 on the outside. So on my inverse, I'm going to do the opposite of that, which would be plus 3 on the inside. And that's my final answer. By the way, if you put a plus or minus in here, I would have been okay with that. Technically, it wouldn't be a function, so I'm not bothering with that one. Okay, thanks. Good luck on your test.